welcome back and we'll be doing class 7 physics today, and we'll be continuing with the topic that we have started last week, that is magnetism. So we'll continue with magnetism. So in the previous class we learned about what is a magnet, what are different types of magnets, and what is magnetism. Okay, so today we'll continue with the properties of magnet. Okay, so as you can see over here, the properties of magnet, as we say, so there are, as we read the properties of magnet, there are north poles and south poles. So this is something we've discussed this earlier. Okay, a magnet always exists in pairs. That means a magnet always has a north pole and a south pole. See, this is a magnet. Okay, if this is a magnet, it will have a north pole and it will have a south pole. Okay, so that means it always exists in pairs. That means it always have two poles that are north and south. Okay, magnets have a magnetic field around it. So we discussed this, what is a magnetic field, isn't it? So magnetic field means the region or the space in which the magnetic force can act. That means in a particular zone around the magnet, it can attract the magnetic materials or another magnet. So the zone in which the magnet can act, or its force can act, is called your magnetic field. So the third one is like poles repel and unlike poles attract. So this is something that you all know very well, isn't it? Say if this is a magnet and say this is your north pole and this is your south pole, and this is another magnet and say this cap is representing the north pole and the bottom is your south pole. Now if you bring the north and the north together, what will happen? They will repel. You've experienced it yourself, isn't it? When you bring the two magnets together and if you bring the poles together, what will happen? They will repel. No matter how hard you try to bring them closer, still they will move away. There will be no attraction. So it means like poles repel. That means north repel, north pole. South repel, south pole. But if you just flip the poles and say you have a south pole here and then the north pole, what will happen if you bring them together? Attraction, isn't it? They will be attracted. So what does it mean? It means unlike poles attract. Okay, so the third property is like poles repel and unlike poles attract. Okay, the fourth one is magnetic forces attract only magnetic materials. So if you use a magnet to attract this system, it will not be attracted, isn't it? It only attracts iron and aluminium and other magnets. Okay, so it only attracts magnetic substances. The fifth one is magnetic forces act at a distance. So this is like the magnetic field that we discussed. If this is your magnet and say this is a magnetic substance, if you keep it very far, it will not be attracted. But as you bring closer, what will happen? There will be, the force of attraction between these two magnets will be seen or can be felt. Okay, so as you bring them together, as you bring it closer, this magnetic substance or a magnet will start getting attracted to the magnet. You can feel that force. So that is what it means. Magnetic force acts at a distance. Okay, now see here. Magnet has two poles. As we discussed, north and south. Okay, where the magnetic force is strongest. That means the magnetic force is strongest at the poles. You bring a magnetic substance here, it will definitely be attracted, but it will be, the attraction will be immediate at the poles. So what does it mean? It means that at the poles, the magnetic force is the strongest. Another one is when a magnet is suspended freely, it comes to rest in the north-south direction. So what you can do is you can just tie a magnet. Okay, you can tie a magnet with a thread, and when you hang it, what will happen? And just move it for a while, it will be disturbed. After some time, it will come to rest. When it comes to rest, one end will be pointing towards the north direction, that is north pole, and the other will be pointing towards south. Okay, what does it mean? It means that it always comes to rest in the north-south direction. Okay. So the third one is magnet always attracts objects made of iron and steel. So this is something that we discussed in the beginning only, that magnets only doesn't attract all the metals. It only attracts certain metals, and they are iron and steel. And poles always exist in pair. That means you cannot have one magnet which only has north pole and no south pole. Okay, a magnet will always have north pole and a south pole. You break it into smaller pieces, it will still have north and south pole. So no matter how many times you break it down, it will still have two poles. Okay, and this I'll be showing you later. As of now, just understand that magnet, they always come in pairs. Okay, that means the magnet always has two poles, one north pole, the other one has south pole. Now, further discussing about the properties of magnets. So, listing down, the topic listing down, the first one we have is attractive property. So, what is attractive property? Attractive property means magnet attracts other magnetic materials or other magnets. Okay, magnet always attracts magnetic materials. That means materials which are made up of iron and steel, and it also attracts other magnets. Okay. Repulsive property. Now, repulsive property means a magnet always repels another magnet if the two poles, the two similar poles, are brought closer. So we'll discuss this more further. This is repulsive property comes under this one. Unlike poles attract and like poles repel. Okay, the third one is directive property. And directive property means when you hang a magnet freely and when it comes to rest, it always points towards north and south direction. Now, the first one that we're going to discuss is directive property. We said this already. You hang a magnet, and when a magnet comes to rest, it will always be pointing towards one end will be pointing towards your north, and the other end will be pointing towards your south. Even if when you play with the compass, not the compass used for geometry, okay, for constructions. I'm talking about the magnetic compass. You might have seen it, the one with the arrow, red arrow, and then it deflects. Okay, the magnetic compass that we are talking about, okay, if you just place it on the table and it's working fine, then it will always be pointing towards north and south. When it comes to rest, one point will be swinging towards the north, other will be swinging towards the south. And even the Earth, Earth is a huge magnet, it's considered to be a huge magnet itself, isn't it? And that's why even the Earth has two poles. One is north pole, the other is south pole. Another one is your attractive property. So a magnet can attract any magnetic substance. So if a substance is getting attracted to a magnet, it means it is either a magnet itself or it is a magnetic substance made up of iron or steel. Okay, so magnet attracts all substances made of iron, nickel, cobalt and their alloys, and these substances are called magnetic substances. So substances which get attracted to a magnet are called they are called magnetic substances. Okay, now we know this opposite poles attract and similar poles repel. So when you bring the south pole and the north pole together, there will be attraction. But if you bring south and south together, they will repel. That means they will move away from each other. They will not be attracted to each other. They will be moving away from each other. Similarly, when you bring north and north together, they will again be moving away from each other. Which means like poles repel and like poles attract. Now, Testing for magnetism. Now, how do we know whether a substance given is a magnet or not? Okay, say if I'm given the substance and say if I have to test whether it is a magnet or not. So what you have to do over here is say you keep a magnet. Okay, you place a magnet, and I have this substance. Now I have to see this whether this substance is a magnet or not. So I already have a magnet. I bring it closer to the magnet. Okay, I bring it closer to the magnet. If it's attraction, it doesn't prove that it's a magnet. If there is attraction, it will not prove. Please listen to this carefully. If it's attracted to the magnet, it does not prove that this is a magnet. Why? Because a magnet gets attracted to a magnet, but also a magnetic substance gets attracted to a magnet. So it's not clear whether this is a magnet or magnetic substance. Okay. It can be a magnet, another magnet, or it can be a magnetic substance. So we are not sure if there is any attraction between them. For you know that there is attraction between two magnets if you bring the unlike poles together. Now, what if you bring the like poles together? Say, if you just turn this and if you just bring them together, if you bring the substance and the magnet together, and if there's repulsion, if they are not attracted, if they're just moving away from each other, then it is a sure test. That means it is a confirmed test that this is a magnet. So what does it prove? It means repulsion is a sure test of magnetism. Which means if you want to find out whether a given substance is a magnet or not, you just have to bring it to a magnet and then see if there is repulsion or not. If there is repulsion, then it surely means that the given substance is a magnet. But if it's an attraction, it doesn't prove that the given substance is a magnet. It can be a magnet, it can be a magnetic substance. So if there's attraction, it doesn't prove. That's why we say repulsion is a sure test of magnetism. So you can see over here, only repulsion between a specimen and a magnet allows us to specify is a magnet. Attraction between a specimen and a magnet only suggests that the specimen may be a magnetic material or a magnet. Okay, so you have an experiment over here. What you need to do, you need to take a metal, okay, to know whether that metal is a magnet or not, and a magnet. Then you bring them closer. If there's attraction, it's okay. If there's attraction, it can be a magnetic substance or a magnet. But then you change the direction, you change the pole, okay? When you change the pole and if you bring them closer, and if it's still attracted, it means it is a magnetic substance. But if there's repulsion, if they're repelling each other, that means this is a magnet. Now, another one is poles always exist in pairs. So, let's take an example. Say this chalk is a magnet here. Okay, now it has two poles, as we discussed, North Pole and South Pole. If this is a magnet, we are assuming this to be a magnet. Okay, so this is a magnet. It has two poles, North and South. You break it. Now, what is happening when you break it? Generally, we assume that the North and South is separated, isn't it? The North Pole and the South Pole has been separated. But again, this smaller piece of the magnet will still have North Pole and South Pole. Even the another piece will again have North Pole and South Pole. Okay, when we break, we don't say that the poles have been separated. Even the smaller piece will have North Pole and South Pole. You further break it into smaller pieces. Again, this tiny piece will have North and South. You break it further. Again, this tiniest piece will have North and South. And you break it into the minute, as small as you can. Still, it will have North and South pole. So it means that the poles always exist in pairs in a magnet. So you cannot have a magnet which only has North Pole, or you cannot have a magnet which only has a South Pole. We'll stop here. I hope you've understood till here, and if there's any doubt, any query, please feel free to call me or text me. And after we complete this chapter, not this chapter, after we complete the entire chapters of the book, then we'll start discussing the question answers that we have not discussed. Okay? So thank you and have a good day.